This live SLU show is brought to you by the support of SLU members and the following sponsors. Visit SLU.com to become a member today.
Hi, SLU members, and welcome to the latest Clubhouse Clips show. I'm so excited to bring this really intriguing subject matter to you today. I'm Eric Edelman, broadcasting to you live from Smoky Hollow Studios at SLU HQ in Washington Depot, Connecticut. And today we're going to be looking at really a very, very distant object that in our minds was once a planet, now necessarily not, the dwarf planet Pluto. As today, it's going to be occulting a star, and there's going to be some very, very interesting uh, scientific information that's going to be coming out of that, particularly as we're moving closer and closer toward the close approach of New Horizons as that spacecraft heads toward the dwarf planet. And so accompanying me here today is going to be SLU astronomer Will Gator, who's going to really take us into some of the more intriguing aspects of both this event and the event to come. And so welcome, Will, to the show. It's great to have you on.
Hi, Eric.
And so there's a lot to be talked about with this event in particular, a lot to be uncovered, and there's just so much that's happening in the very recent days with new imagery coming out all the time. This is one that's the first color image that we've seen of Pluto, and we're going to go even deeper into the science of today, what's going on with this very particular occultation. And to that end, we have on somebody who's very interested in occultations, who's done observations of occultations before. One of our wonderful feed partners, Jonathan Bradshaw, located in Brisbane, Australia, who's part of the Stanford Valley Observatory, and he's going to be talking quite a bit with Will about the ins and outs of this very, very intriguing event that we have right now. And so uh, I welcome you to take it away, gentlemen. There's a lot to be talked about, and I'm very much looking forward to hearing about it.
Thanks, Eric. Jonathan, great to have you with us here on SLU. You've been observing occultations for many, many years, and I know this is something that you're really passionate about. How excited are you about this particular occultation by Pluto?
It has to be said that this one has got the occultation astronomers absolutely fired up like you wouldn't believe. Um, a a planetary occultation between a planet and a star. They're rare enough as it is. They don't come around. Pluto hasn't been seen to occult a star very many times at all in history. And this one's particularly bright. It's really bright. It's by astronomical terms, it's a 12th magnitude star. Now, that's way fainter than anybody's ever going to see with the naked eye. But in astronomical terms, it's actually quite a bright star. It's 2 magnitudes brighter than Pluto, and that means we're going to gather an awful lot of data about Pluto's atmosphere as it covers that star. So it makes for a very exciting event.
When we talk and we use this word occultation, what do we mean?
So an occultation is simply when one body goes in front of another. Now, there's the most
Right, so that's
spectacular, I guess.
essentially the thing that I like about occultations, we call things like solar eclipses, but if we're actually being technical, we should say it's an occultation of the sun, shouldn't we?
Absolutely, the moon is occulting the sun, and it does a fabulous job of doing it. And a really bad job of occulting is a transit. So when we all sat and watch the transit of Venus, and upcoming next year there's a little transit of Mercury, that's a pretty poor attempt, a lame attempt by a planet to occult the sun. It doesn't do nearly as good a job as the moon does, but it is an occultation. So transiting exoplanets, your last show, is an occultation. It's an
Yep.
exoplanet going in front of another body, and it's casting a shadow. It's a little shadow, but it's a shadow nevertheless. And it's those shadows that we're chasing.
We were hoping to bring some live images of the Pluto occultation, but actually, unfortunately, it sounds like the weather over there in Australia has sort of conspired against us. Unfortunately, hasn't it?
Yeah, I am occulted by cloud. It's unfortunately one of the painful things about trying to observe live astronomical phenomena. Unlike taking a photograph when you can wait to the absolute perfect moment and go out with your camera and point it and take that photograph, when you're observing an occultation, they tell you when they're going to happen.
Yeah.
And inconveniently, it's clouding.
But there is actually a mission, isn't there, that's going to go above the clouds? You know, they're quite lucky. NASA's Sophia mission, which could you tell us a little bit about this incredible sort of telescope in a 747?
Yeah, no, that's right. I'm trying to remember the size of this instrument. It's actually quite a significant telescope. Is it a 2 point something meter telescope? It's
Yeah.
designed to gather its data in the infrared, and that's one of the reasons it needs to get up high. Infrared is, of course, absorbed by the atmosphere. Um, so to get good infrared observations, it needs
So
to get above the
this
atmosphere, and
is
it
the
goes
live
up
view.
to
Actually,
50,000 feet.
we can show it tracking. It's just south of New Zealand at the moment, but it's been in the air for a few hours now, and I think it's flying about 35,000 feet from what I can gather. And they're going to be doing
Yeah.
lots of observations.
Yeah, so they and I don't know how these things work. I mean, it's the wonders of physics and engineering that literally the whole side of this plane towards the rear opens up, and this telescope points through the back of it. And it's if you imagine the old Hercules or the old military bombers with the rear that opens up so that parachutists can get out. This one actually opens the side, and this telescope sticks out. And it is a miracle of engineering that it can be sufficiently stable to get these observations, and it really demonstrates just how important this particular event is. This is the first time, that this brilliant jet has come down to New Zealand, I believe, to do this observation, and everybody's fascinated. They've made a prediction, and that plane you can see on front of you is basically following the path of the central line of that prediction. So we're going to get to see how accurate that prediction is.
Yeah, it's not just extraordinary engineering, it's extraordinary effort that obviously professional and amateur astronomers are going to observe this occultation. Why is that? I mean, can we learn from an event like this?
So the data which has been collected from if we look at how an occultation works in general. First of all, it's this giant laboratory in the sky called the solar system. It's not done down on Earth. So what we're looking at is outside of our atmosphere. Our atmosphere causes all sorts of effects. It blurs stars. It makes all of our observations fuzzy and less accurate. So when an occultation happens, if it was an asteroid that goes in front of a star, we get a really, really accurate understanding of the size and composition of that object. Now, when Pluto went in front of a star back in 1988, I believe, the first time it was properly observed occulting a star, we noticed that it didn't go straight out. The light curve dropped off gradually, flattened out at the bottom, and then it picked up again. And that was the first confirmation that Pluto actually has an atmosphere. Not only that, the nature of that light curve went from shallow to steep to fully flat. Then not only has it got an atmosphere, it's got multiple layers of atmosphere, and that's what we learned. These observations, these higher quality observations, will further refine that data. And if they manage to get right on the central line, there's a thing called a central peak. It's basically the light getting refracted around. And there you have an observation that I did in 2012, which just shows that it was only a very, very faint occultation. There was only 0.2 of a magnitude drop. You couldn't even detect it with the naked eye, but the camera can detect it. And that faint central peak gives some information about the density of that atmosphere. And also, if
So,
they take it in different wavelengths, they can also see whether Pluto is windy, of all things. They can actually work this out with data from light curves just like this one.
it's extraordinary what this sort of light curve, and this is what we call this graph. It's extraordinary that all that information is sort of hidden in there, and it has to be teased out. You spoke about that central flash. This is an interesting term I've never heard before. What causes it?
It's literally, if you like, so I'm told that uh, the effect of the light. So if you're looking directly at Pluto as an object and you have the star directly behind it, all of that light is shining, and some of that light is refracted around like a lens back to the front again. Okay, and it gets
Right.
focused back on the front.
See.
It's like the halo behind of light coming around, and it's seen if you're right in the middle, right at the center of that flash. And we've been looking at these central flashes and trying to find them in the last few months as the Jovian, Jupiter's moons, have been interacting. They've been doing this as well. They've been occulting each other and they've been eclipsing one another. And if you get them just lined up, you get these central flashes, and they tell you a little bit about the data, because of course some of them have, particularly Io has a lot of atmosphere and dust around it. So lots of information to come out of these bizarre events.
How often does an occultation like this happen? I mean, is it a particularly rare event, or does it change over time?
The problem with Pluto events in particular is the fact that well, it's not too bad with a faint a faint object, but a planet such as Pluto doesn't tend to occult a star very often. Um, the reality of it is there's not much of our solar system or much of our universe is actually occupied by stars. We've got a few billion of them, but they're all very, very small in the night sky. They literally, whilst they look like a blur, like a blob, um, you know, that image of Pluto, you could probably quite say that a star is about a milliarc second across in reality once you've taken out of it, once you look at it through the atmosphere. If you
Mm.
took every single star that you can see in the best sky ever and you arrange them edge to edge, you could easily fit them in the circle of one of those stars on the screen at the moment. Okay.
It's remarkable, isn't it? But
All
I
of
don't think we
Yeah,
really have a innate grasp, do we, of just how difficult and important, I guess, it shows that these events are.
yeah.
We've actually got some a view from 2008 of a Pluto occultation, and I wonder if you can take us through it. It shows us exactly what you'd see, I guess, if you were obviously had a camera for an eyeball. But in this sense, this is what happens. We're looking at a tiny little star in the center, and this is what we're waiting for, right?
Yeah, no, absolutely. So the object in the middle is the star. You can't see Pluto because the two are actually physically merged. Um, but and again, it's back to that thing. They're both two tiny, tiny objects, but the blurring of the atmosphere makes them look like one. They're a similar sort of magnitude. And this is from Dave Galt, a friend of mine down in the Blue Mountains, who's a brilliant and absolutely dedicated occultation observer and got some fabulous data off this. And you can gradually see it fading out. So the
Isn't
whole
that remarkable?
occultation takes about a minute. And look how quickly it's going now.
Right
So
before
if
your
we were
eyes, it
to
just fades away, doesn't it?
Yeah, and it's literally just fading away to nothing. Now, if that was an asteroidal occultation with no atmosphere, it would have just gone out.
Mhm.
Just gone out. So then it's gone. What you can just see now is Pluto. You can't see the star anymore. We've started off by seeing the light from the star, and now we can see just faintly in the middle there the light from Pluto,
It's remarkable.
which of course is the light from our sun because it's reflected off it.
Yeah,
So
it's remarkable, I think, isn't it, what you're actually looking at there? And then
yeah,
slowly, I guess it appears to sort of climb back.
Yep, absolutely. So we're just waiting for a few seconds, and is it beginning to start? And it will just pull back normally. And normally, normally these things are symmetric. They're not always symmetric for various reasons, but they're normally symmetric. We actually discover due to asymmetry when you have double asteroids, for example,
Right,
because
and
you have a big asteroid and a small one going beside it, and they make a slightly different pattern as they come out. So we've discovered double asteroids like that. There, she's coming back
and I
now. So
and I
she's
presume
making.
things like ring systems and moons would show up if we were, looking with high resolution equipment at this Pluto occultation. Is this something that amateur
Yep.
would within reach of amateurs maybe?
Yes, no, absolutely. So, um, with very highly sensitive cameras, which aren't necessarily expensive, we look at the beautiful CCD cameras that astrophotographers take and spend many thousands of dollars on. Um, Actually, look how bright Pluto is again now.
Mm,
Um,
that's right.
the sort of cameras that we use are actually akin to CCT cameras used in car parks. You see,
Right.
we have exactly the same thing in common with a car park security cam needs. They want to see movement in really, really, really low light, and that's convenient for us because it means that there are bazillions of them. And
Yeah.
due to the joys of mass production, it means we can buy an incredibly sensitive scientific instrument for a few $100s, which we normally put in a car park. And that's what we use.
Just,
And you can put one of that on even a modest amateur telescope will allow you to do this. You don't. It's not a big financial outlay. A modest.
mm,
What you need is a little bit of a little bit of technical know-how because, of course, there's electronics involved and data capture, and a bit of dedication, and you can be out there making really big scientific contributions.
But that's one of the interesting things I think about occultation, timings and observations. I mean, we saw that beautiful light curve there from Dave, and this is real science. There's the potential to, as you said earlier, not just observe Pluto in this case, but asteroids. What sort of things can amateurs learn through these sort of events about asteroids and small bodies like that?
Oh, well, asteroids are fascinating objects. We really have been learning a lot. Each time we observe an asteroid, we do a couple of things. We do I guess, most importantly, is we get some uh, ast- astrometry. So we get, it's like geometry only in the sky. It's positional data. Okay, so we can actually work out exactly where that asteroid is, and we can work out the size. So with an on-off occultation, you get a thing which is called a chord, and that's the light curve. If you imagine that Pluto one before,
Mhm.
you know when it started and you know when it ended. If a few of you observe this, if you get the number of people observing that and you get several chords, they line up just like a jigsaw, and you get a profile of the asteroid. A lot of them are circular, but there are a lot of irregular asteroids out there, which you can find. I had two grazing occultations of asteroids where the because of the irregular shape, the light curve has gone off, then it's come back on, and it's gone off again.
So essentially,
We've
almost,
discovered double act.
is it right to call it like sparkling? It almost seems as if you sort of have
Yeah,
that sort of little bit of brightness.
yeah, no, it's really unexpected. We've discovered double stars in occultations because we think the asteroid is going over a single star, but it goes over a double star. And what happens is the light of the smaller star goes out first, and then so you have this stepped event which repeats itself on the way back up. So you end up discovering a double star and getting a name in the Washington Double Star catalog as well, because that's just a entirely surreptitious discovery. Um,
Yeah.
it's you
And I,
never quite know what you're going to find. A lot of them are just pretty. They don't have a
yeah.
massive payload. Others give you unexpected, interesting things happening.
The thing that always amazes me about these events like occultations is how quickly they happened. I mean, going back to this Pluto
Hmm.
occultation, how long, for example, if we had perfect conditions, or maybe the people on Sophia, how long would would
Yep.
that it actually last? Similar to the video we just saw?
Yeah, absolutely. It's looking at about a 60-second event. They're more predictable than the or they're more consistent than the asteroidal events because you're looking at an object which is so far away. With the asteroidal events, they can go from just a few seconds, which is normal, to quite long, depending on where it is in the orbit in relation to the Earth. So if you imagine it's coming towards you, it's actually effectively traveling really, really, really slowly. And therefore you get longer occultation. Whereas something like Pluto, pretty consistent. It's a long way away. It's
Right.
moving at this steady rate. It's always about a minute. If they're bang on the central line, they've got about a minute. I'm not entirely sure how the speed of that aircraft is going to affect it in the way that it can affect a solar eclipse.
Well, let's hope they have a really successful flight and observation on Sophia. Thank you, Jonathan, for speaking to
Yes,
us here
that's
at
quite
SLU.
right.
It's been fascinating speaking to you. And I'm going to hand back now to Eric at Smoky Hollow Studios for the end of the show.
Oh yeah, it was so great to hear really a lot of what you guys were talking about here, because there's so much going on behind the scenes of this event. Like we think of different, like the Saturn occultation that happened a while ago. We think of eclipses, and we see these beautiful events that pass right before our eyes that are really dynamic and really intriguing, but they also have so much science and intrigue behind the scenes that we get to explore and discover. And so
Yeah.
it's great to just get a little bit more background, I think, on all these things that are happening in the night sky, as well as being able to experience them before our eyes. And so I hope that you folks were really enjoyed the occultation that we did see, a wonderful video contribution from one of our feed partners that showed, while we weren't necessarily able to see it live because of the clouds occulting our field of view here, that we were able to see sort of what would have maybe approximated a similar sort of experience with a Pluto occultation. And so, as of course, as we're going further and further in, there's lots of more events right on the horizon. Uh, you know, a little bit pun intended, New Horizons is going to be coming in the middle of this month, and we're going to be covering that event live. And of course, we have just a bunch of events stacked up just in this coming week. Tomorrow, we're going to be celebrating Asteroid Day and spreading awareness of asteroids and interviewing some very intriguing people that have a lot of expertise in the subject. And then following that, there is a very nice conjunction that's coming up, the conjunction of Venus and Jupiter, just the following day, where we're going to see these two planets that are really great to see individually in a telescope together in the same field of view of a single telescope. And so since they're so close in the sky, we're going to be able to do that. And so really just stay tuned in the clubhouse for what's coming up next, because there's always going to be shows coming up very soon. And so it's going to be a lot of fun to go through these next few weeks with you folks. And so if you have anything that you're interested in hearing about that's might be happening in the night sky, or just that you're intrigued about astronomy wise, do let us know. We might be able to do a show about it. Yeah, but for now, this is sort of the end of our foray into Pluto for right now. But there's certainly a lot more to come as we're sort of wrapping up this Pluto show. Any sort of last thoughts from you, Will, on what this occultation will bring, what what will come with New Horizons? Lots of exciting things coming up.
Yeah, I just thought this, what Jonathan was saying about the sort of science that amateurs can do, that just fascinates me. And I think that's the sort of thing that you have to always remember, is astronomy is one of those subjects where everyone can make a contribution, and a real contribution, not just some sort of, going through the motions and pretending to be a scientist. You can actually go out there, whether it be with your own telescope in the back garden, or SLU's telescopes, or robotic telescope, you can really actually make a contribution to science. And I think that's what's so exciting for me about events like this.
Oh, absolutely. And I mean, it's such a great message for SLU members to hear, really, because we've been imaging Pluto in the clubhouse for a while now. And that's something that, if you control its telescopes, you can do that. And so, if you're intrigued by a subject, you can really be involved in it, not only seeing it, but also helping the scientific community learn more about it. And so explore your own horizons as New Horizons explores Pluto, really. And so that's about it for us today, but we will be on tomorrow and the next day, and so be sure to get your fill of SLU shows. But for now, this has been Eric and Will for SLU. We'll see you again. done observations of occultations before. One of our wonderful feed partners, Jonathan Bradshaw, located in Brisbane, Australia, who's part of the Stanford Valley Observatory, and he's going to be talking quite a bit with Will about the ins and outs of this very, very intriguing event that we have right now. And so I'd welcome you to take it away, gentlemen. There's a lot to be talked about, and I'm very much looking forward to hearing about it.
Thanks, Eric. Jonathan, great to have you with us here on SLU. You've been observing occultations for many, many years, and I know this is something that you're really passionate about. How excited are you about this particular?
Us into some of the more intriguing aspects of both this event and the event to come. And so welcome, Will, to the show. It's great to have you on.
Hi, Eric.
and so there's a lot to be talked about with this event in particular, a lot to be uncovered, and there's just so much that's happening in the very recent days with new imagery coming out all the time. This is one that's the first color image that we've seen of Pluto, and we're going to go even deeper into the science of today, what's going on with this very particular occultation. And to that end, we have on somebody who's very interested in occultations, who's
This live SLU show is brought to you by the support of SLU members and the following sponsors. Visit SLU.com to become a member today.
Hi, SLU members, and welcome to the latest Clubhouse Clips show. I'm so excited to bring this really intriguing subject matter to you today. I'm Eric Edelman, broadcasting to you live from Smoky Hollow Studios at SLU HQ in Washington Depot, Connecticut. And today we're going to be looking at really a very, very distant object that in our minds was once a planet, now necessarily not, the dwarf planet Pluto. As today, it's going to be occulting a star, and there's going to be some very, very interesting scientific information that's going to be coming out of that, particularly as we're moving closer and closer toward the close approach of New Horizons as that spacecraft heads toward the dwarf planet. And so accompanying me here today is going to be SLU astronomer Will Gator, who's going to really take